Okay, so that gets us to solving quadratics by extracting roots. And to do that, we're going to use something called the square root property of equations. And what this says is if I have a squared equals b, what I can do is I can root both sides of that and undo the square. So given a squared equals b, if I take the root and then that plus or minus, I get a equals plus or minus root b. So what this is saying is a could be negative root b or positive root b. And the reason for that is if you think of something like x squared equals 25, there are two values that make this true. Negative 5 times negative 5 would make 25, as would 5 times 5. So when I take the root, I have to allow for both possibilities, the positive and negative roots. So when we're solving using the square root property, what we're going to want to do is isolate the quadratic term to make its coefficient 1. So say in this example I had something out front, I'd want to get that by itself, and then we use the square root property. And then it may be we need to simplify a radical. So here I got square root 25, so I would want to make that plus or minus 5. So this first one here, x squared equals 49, let me remind you that if I factor this, I would get x plus 7 and x minus 7. And this should have two answers because I have two x's. So if I do this by extracting roots, I'm going to have square root on both sides. And here's that plus or minus that I would get from the two separate factors. And we'll actually see that coming up in the next section. So plus or minus 49 would be plus or minus 7. You can see here if I put a negative 7, it comes out to 0. If I put in positive 7, that would also come out to 0 for that factor. So here my two solutions are x equals negative 7 and x equals positive 7. This one, let me rewrite that over here. And so that y squared up in the numerator, I can also think of it as just multiplying. And then to get rid of this 4/3, I'm going to multiply both sides by the reciprocal, because what I want to do is I want to get this isolated. And then here we're going to have 24 over 4. That reduces to 6. And so root both sides, and y equals plus or minus root 6, or y equals negative root 6 comma root 6, depending on how they have it formatted. So for number 6, we want to isolate the squared, so we're going to bring the 350 over, and we'll have y squared over 2 equals 200, and then we'll multiply both sides by 2 to get the square by itself. And y squared equals 400, and then we can root both sides. And y equals plus or minus 20. And so again, that in the answer box, if it has y equals, you would have negative 20 and 20. These next couple of the same idea, it's just these ones will come up to decimals. So this first one, let me write that a little bit bigger. So here we bring the 3a squared over, because again, we want to get our a squared, our squared term by itself. And we get negative 4 equals a squared. And if you notice, so if I write that the other order, it looks a little bit better. So there are no two numbers that multiplied, well, there's no number that multiplied by itself makes negative 4. If I do 2 times 2, I get 4. If I get negative 2 times negative 2, I get 4. And so if you think about in terms of the parabola, when we were graphing a squared plus 4, we would get something that looks like this. And so we're not getting any intersection points down here at the x-axis, and that's what extracting the roots is finding, is those x-intercepts, or those zeros. And so that's why sometimes we have no x-intercept, is because it's above or below the axis. For this one, let me write that bigger. So here we want to isolate the squared term. And that will get us on this side 1.6t minus 76 equals negative 49. And then from there we'll add over the 76. So 1.6t equals 27. And then divide over that 1.6. Oops, I dropped my squared up here. And so now I have t squared equals, that came out to 16.875. And now to undo the square again, I use my root with my plus or minus. And then this asked me to round to 2 decimals. And so when I threw that in the calculator, I got negative 4.11 and then positive 4.11.